Hello, I'm Jared Vaudry, Field Chief Data Scientist at Domino. Today we're going to review a RAG system developed, deployed, and optimized within Domino. For those of you who are not familiar, RAG, or Retrieval Augmented Generation, is made up of two main components. The retrieval component, which helps us find relevant information from a collection of documents, and the generation component, which creates human-like responses based on the retrieved information. You can think of RAG like a smart research assistant that has access to your document collection, can quickly find relevant information, can explain that information in a natural way, and cite its sources. What I have up on the screen is a lightweight UI that we've built to demonstrate document search using RAG. There's a lot of features here that are not relevant to an end user. We've added them to demonstrate how changes to the various configurations impact the quality of results. You'll see a lot of tutorials out there with titles such as RAG in 13 lines of code and companies offering out-of-the-box turnkey solutions. It's our experience that they only get you a little bit of the way to a production-ready solution. This is where Domino comes in. Domino is a platform that not only helps set up and deploy a RAG system, but also helps organizations optimize the configurations to internal data and usage patterns, going 100% of the way there to get you to a production solution that is accurate for your scenario. I'm going to go ahead and quickly upload a Tesla financial document that I found online for this demo. We're processing through data preparation tasks here, including OCR to make sure graphs and images are included, applying this selected chunking strategy, and then transforming the resulting text into embeddings. There's a lot of different chunking strategies and embedding types, so you can see there's already a lot of decisions we've made to configure our RAG system. We're not even at retrieval yet. Let's take a look at some of the other parameters we need to consider. What LLM, retrieval details, if we want to use a re-ranker. As I mentioned, there's a lot of decisions to make here, and that's why out-of-the-box solutions sometimes struggle. It's a hard problem to generalize. This is where Domino really shines in this context. Taking a look at the system's architecture here, we have a few different workflows. Our first workflow at the top is use the cold start. We prepare data, apply chunking, transform text to embeddings, and actually run a set of prepared prompts automatically through the system to understand the accuracy. We run a grid search across parameter options to measure the impact on our known outcomes. We have a notebook for this that we provide as a Domino template that conveniently captures the results in Domino's experimented tracking feature. This allows us to determine the optimal starting parameters. Now we are ready to launch our system, which we make available as an agent through Domino's AI Gateway, an endpoint to LLMs and agents that standardizes the outputs and only requires a single one-time setup. Behind the scenes, prompts can be filtered against guardrails, then processed through our RAG system. We actually use the AI Gateway a second time here to point to a Domino deployed LLM, which we'll fine-tune in the next flow. This could also be a third-party LLM as ChatGPT or Claude. Again, the results are standardized, so it's easy to test out different algorithms. Another decision we can optimize. One value out of this approach is we can capture our usage data to analyze later as shown in this report. For those interested in guardrails, we demonstrate three approaches in this template. First, we're using pattern matching via regex to identify IP addresses. Second, we use few-shot learning to give a small language model examples of an item or topic to identify. This approach works really well for identifying things like addresses, which are hard to capture via a pattern due to the number of variations. Finally, we incorporate a third-party package, TensorFlow Toxicity. These can be applied on data coming in to prevent data loss if using, say, a third-party LLM, or on data coming out to align the results with expectations. Let's now run a query against our demo app. We're hitting the RAG system and it comes back with Tesla. We've got a citation, Tesla is correct, and so I'm going to thumbs up this result. This is where our third dominant workflow comes into play. What this allows us to do is capture that user feedback, and then we can trigger a Domino job every, say, 10,000 data points, which kicks off a model fine-tuning pipeline. We can apply our governance policy to make sure it's the accuracy level we want, and then either automatically or manually review and deploy using Domino ML Ops capabilities, which then again feeds our AI gateway, completing the closed-loop system. The advantage here is this is all happening within Domino. We have a system of record, automated infrastructure deployment, automatic model deployments, scheduled jobs, AI gateway, governance, all of the features that are required to easily launch a complex system like this. If this short overview piques your interest and you would like to learn more, please reach out to us here at Domino for a deeper dive.